On March 8, 2025, at exactly 2:47 a.m. Greenwich Mean Time, every GPS satellite in the European constellation experienced what engineers are calling a synchronized timing anomaly. For 11 minutes, navigation systems across 14 countries reported positions that were off by hundreds of meters. Cars using autopilot drifted into wrong lanes. Cargo ships recalculated their routes. Emergency services temporarily lost the ability to locate callers in distress. Then, as suddenly as it began, everything snapped back to normal. The satellites resumed perfect function. No explanation was issued, no public inquiry was launched, and here's the part that should keep you awake tonight. At that exact moment, 2:47 a.m. GMT, the James Webb Space Telescope was conducting its 47th observation of an object in deep space. An object that shouldn't exist according to our current understanding of stellar formation. An object that, 3 days after this GPS incident, began emitting a radio signal pattern that has never been observed from any natural celestial body in the history of astronomy. 2 technological disruptions, one terrestrial, one cosmic, separated by 93 million miles and connected by a timestamp that defies the mathematics of coincidence. Tonight, we're going to follow a thread that connects quantum entanglement research, military satellite networks, and an astronomical anomaly that has scientists deleting their social media accounts and refusing interviews. Stay with me until the end, because what we've uncovered will fundamentally alter how you think about what's watching us from the dark. If these questions are burning in your mind like they're burning in mine, don't stay passive. Hit that like button and subscribe right now, because this story is developing in real time, and you need to be here when the next piece drops. Comment below with your location and whether your GPS has done anything strange in the past month, anything at all. And if this investigation resonates with you, share it everywhere. X, Reddit, Discord, your group chats, anywhere people are still asking real questions. You are the reason we can chase stories that powerful interest would prefer stayed buried. Thank you for being here. Let's begin. You probably think you know how GPS works. Satellites send signals, your phone triangulates, you get directions to the nearest coffee shop. Simple, reliable, boring. Except GPS isn't simple at all. It's one of the most precisely engineered systems humanity has ever deployed, and it operates on principles that sound more like science fiction than civil engineering. Every GPS satellite contains an atomic clock accurate to within billionths of a second. These clocks must be perfectly synchronized across the entire constellation, because GPS doesn't actually measure distance, it measures time. The satellites broadcast timestamps, and your device calculates how long those signals took to arrive. Light travels at a fixed speed, so time differences translate to distance differences, and distance differences from multiple satellites let you calculate position. But here's the thing that most people don't know. Those atomic clocks run faster in orbit than identical clocks on Earth's surface, not because the clocks are broken, but because time itself flows at different rates depending on gravity and velocity. This is Einstein's general and special relativity, not theory anymore, but engineering requirement. GPS satellites experience weaker gravity than we do on the surface, which makes their clocks tick faster by about 45 microseconds per day. Simultaneously, they're moving at 14,000 kilometers per hour, which makes their clocks tick slower by about 7 microseconds per day. Net effect, they gain about 38 microseconds per day relative to ground clocks. That might sound insignificant, but light travels 30 centimeters in 1 nanosecond. 38 microseconds is 38,000 nanoseconds. If we didn't correct for relativistic effects, GPS would accumulate errors of about 11 kilometers per day. Your navigation system would be useless within hours. So every GPS satellite constantly adjusts its clock to compensate for the fact that it's experiencing time differently than you are. It's measuring one flow of time and reporting another. It's performing a relativistic translation between reference frames, billions of times per second, perfectly synchronized across dozens of satellites. When that system experiences an anomaly, when those clocks suddenly disagree with each other or with ground stations, it's not a simple malfunction. It's a disruption in the fundamental synchronization of time measurement across different reference frames. And that's what happened on March 8th. The first report came from the European Space Agency's Galileo Control Center in Oberpfaffenhofen, Germany. At 2:47 a.m. GMT, multiple Galileo satellites simultaneously reported timing discrepancies, not drift. which is gradual but sudden offset, as if someone had reached into orbit and physically adjusted the clocks by several microseconds all at once. Ground stations immediately began transmitting correction signals, but the satellites weren't responding normally. They acknowledged the corrections but didn't implement them. They continued broadcasting timestamps that were detectably wrong by about 340 nanoseconds. 340 nanoseconds translates to about 100 meters of position error. That might not sound catastrophic, but consider what was happening in those 11 minutes. Autonomous vehicles using GPS for lane keeping suddenly saw the road shift beneath them. Aviation systems reconciling GPS with inertial navigation got conflicting data. Maritime shipping in the English Channel, one of the world's busiest waterways, temporarily lost precision positioning, and here's what didn't make the news. During those same 11 minutes, the European Union's emergency services dispatch system logged 437 calls where location services failed to accurately pinpoint the caller. Most of those were routine, some weren't. We know about 3 specific incidents where emergency response was delayed by those 11 minutes. The details aren't public, and they won't be, but people who work in those dispatch centres will tell you off the record that March 8th was a very bad morning to have an emergency. At 2:58 AM GMT, the anomaly resolved. Satellites snapped back to correct timing simultaneously. No gradual correction, no drift back to normal. One moment they were wrong, the next moment they were right. European Space Agency issued a brief technical notice attributing the incident to a software glitch in the ground control system. They promised a full investigation. That investigation's findings have not been made public. When pressed, ESA representatives say the matter is resolved and there's no ongoing risk. They will not elaborate on the root cause. They will not explain how a ground control software glitch could cause simultaneous timing offsets in satellites that maintain independent atomic clocks. They will not explain why the satellites didn't respond normally to correction signals. And they definitely won't talk about what the James Webb Space Telescope was looking at when it happened. Now, you're probably thinking this is where the script takes a hard left turn into speculation territory. That I'm about to connect unrelated events through conspiracy logic and call it investigation. I understand that reaction. It's healthy skepticism. But before you dismiss this, I need you to consider something about how discoveries actually happen. Scientific breakthroughs rarely come from people studying obvious connections. They come from people noticing patterns that aren't supposed to be there. Correlations that seem absurd until suddenly they're not. Galileo noticed that different masses fall at the same rate. That seemed wrong until it became the foundation of mechanics. Einstein noticed that the speed of light doesn't change regardless of observer motion. That seemed impossible until it became relativity. Every major paradigm shift in physics started with someone saying, wait, these two things that shouldn't be related appear to be connected, and then following that thread despite being told they were wasting their time. So when I tell you that at 2:47 AM GMT on March 8th, while European GPS satellites were experiencing synchronized timing anomalies, the James Webb Space Telescope was pointed at an object designated JWST DET2501, an object that has characteristics no known natural formation should possess. I'm not asking you to believe in a connection. I'm asking you to consider whether the correlation is worth investigating. Because here's what we know about JWST DET2501, and I want you to really hear this. The object was first detected on January 14, 2025, during a routine deep field observation. It appeared in multiple wavelengths simultaneously, which is normal. What wasn't normal was the spectroscopic signature. Most celestial objects emit light in patterns that correspond to their composition. Stars have hydrogen and helium lines. Nebulae show oxygen and nitrogen. Planets reflect their stars' light with absorption bands from atmospheric molecules. JWST DET2501 shows none of these patterns. Its spectrum is almost perfectly flat across wavelengths from near-infrared through mid-infrared. No emission lines, no absorption features, just a consistent brightness that doesn't match any known stellar process. At first, astronomers thought it was an instrument artifact, a reflection or a processing error. But it appeared consistently across multiple observations using different instruments. It's real, it's out there, and it shouldn't be. The next strange thing is its distance, or rather, the fact that we can't reliably determine its distance. Normally, we measure cosmic distances through multiple methods. Parallax for nearby objects, standard candles for mid-range, redshift for distant objects. JWST DET 2501 doesn't cooperate with any of these methods. It shows no detectable parallax, suggesting it's very far away. But it also shows no clear redshift, which should be impossible for a distant object in an expanding universe. Some astronomers are arguing it might be closer than it appears, but somehow not showing parallax. Others suggest it's incredibly distant, but moving toward us at exactly the rate the universe is expanding, cancelling out redshift. Both explanations require special pleading, neither feels right. The third anomaly is variability. Most astronomical objects are either stable, or they vary in predictable ways. Stars pulse. Black holes flare when they consume matter. JWST D2501 varies randomly. Sometimes it's bright, sometimes dim, with no apparent period or pattern. Astrophysicists have been monitoring it continuously since January, and the variability seems genuinely random. Not chaotic, which implies underlying deterministic patterns, but random, as in no pattern at all. That's deeply unusual. Nature tends toward patterns. Random variability suggests either we're missing an extremely complex pattern, or something about this object operates outside the normal rules. On February 29th, a preprint paper appeared on the ARXIV, the repository where astrophysicists share research before peer review. The paper, authored by 7 researchers from 3 institutions, analysed JWST Det 2501's properties and concluded that its characteristics were inconsistent with any known natural phenomena. They stopped short of speculating what it might be, but they used language that in academic publishing is basically screaming. They called it a challenge to existing theoretical frameworks. They suggested that new physics might be required to explain its properties, and they specifically noted that the object merited immediate follow-up observation with multiple instruments. That paper was online for 16 hours before it was withdrawn. When you try to access it now, you get a message saying the authors requested removal pending further analysis. None of those 7 authors will discuss the object publicly. 3 of them have stopped responding to professional emails from colleagues asking about the observation. One of them deleted their X account entirely. Another gave a single interview to a science journalist and said only that the object required more study, and that premature speculation would be unhelpful. That's it. 7 scientists publish a paper effectively saying we found something inexplicable, then immediately go silent and pull the paper from public view. Now, there are innocent explanations for this. Maybe they found an error in their analysis. Maybe they realized the data was contaminated. Maybe they're preparing a more thorough paper and didn't want preliminary findings circulating. All of those are possible. But when you combine this sequence with what happened next, the innocent explanations start feeling less satisfying. March 8th, 2:47 AM GMT. James Webb was scheduled for observation run 47 on JWST DET 2501. This wasn't a discovery observation. This was follow-up, part of a monitoring campaign to characterize the object's variability. The telescope was collecting spectroscopic data across multiple hours to see if any patterns emerged in the random fluctuations. At exactly 2:47 AM GMT, during this observation, European GPS satellites experienced synchronized timing anomalies. For 11 minutes, 2 independent systems, one measuring the cosmos, one measuring position on Earth, both dependent on precise time synchronization, both disrupted simultaneously. And here's the detail that made me start pulling this thread. The timing anomaly wasn't random. It was 340 nanoseconds across all affected satellites. Not 341, not 339. Exactly 340. In systems where even a single nanosecond matters, where random errors would produce random offsets, every satellite was wrong by the same amount. That's not how system failures typically work. Random malfunctions produce random errors. Correlated errors suggest a common cause, a signal, not noise. European Space Agency maintains that it was a software glitch in the ground control system that somehow propagated identical errors to multiple satellites simultaneously. That's possible. Software can do strange things. But when I reached out to engineers who work on GPS systems, the ones willing to talk off the record, they told me that particular explanation requires multiple unlikely things to happen in sequence. Ground control can send corrections to satellites, but those corrections get processed individually by each satellite's onboard systems. For all of them to implement the exact same incorrect adjustment simultaneously, would require either a very specific bug in identical software running on each satellite, or an external signal that somehow interfered with their atomic clocks directly. The first scenario is possible, but would require the bug to have gone undetected through extensive testing and years of operation. The second scenario is theoretically possible, but would require technology that we don't publicly acknowledge exists. The ability to remotely interfere with atomic clocks in orbit in a coordinated way across multiple satellites simultaneously. Let's pause here and talk about what I'm not saying. I'm not saying aliens interfered with GPS. I'm not saying JWST DET 2501 emitted some kind of cosmic ray that disrupted satellites. I'm not claiming to have proof of anything except the timeline and the public record. What I am saying is that two precisely engineered systems experienced anomalies at exactly the same moment, and the explanations we've been given for both anomalies don't feel complete. The GPS timing offset was too precise to feel like malfunction. The withdrawn research paper was too coordinated to feel like normal academic caution. And the silence from people who usually love to discuss mysterious astronomical phenomena is too uniform to feel coincidental. Something about this situation made people cautious. Whether that something is bureaucratic concerns, scientific uncertainty, or something else entirely, we don't know. But the caution itself is data. Scientists don't usually withdraw papers and stop talking unless they have a reason. So let's look at what happened 3 days later, because that's when this story stops being about suspicious timing and starts being about something that has no conventional explanation whatsoever. March 11th, 2025, approximately 9:15 p.m. UTC. The Greenbank Telescope in West Virginia, one of the world's most sensitive radio observatories, was conducting a routine survey of the sky region containing JWST DET 2501. This wasn't specifically targeting that object. It was a scheduled observation block covering a wide field. But JWST DET 2501 fell within the survey area. At 9:15 p.m, the telescope detected a radio signal from the precise coordinates of JWST DET 2501. The signal lasted for 73 seconds. It operated at a frequency of 420 MHz, which is significant because that's the emission line of neutral hydrogen, the most common frequency in radio astronomy, and also a frequency protected from terrestrial transmission because of its scientific importance. The signal wasn't continuous, it pulsed with a regular period of 0.318 seconds, and here's the part that's going to make you stop whatever you're doing. The pulse pattern was not random, it carried information. Radio astronomers analysed the signal structure and found that it contained a repeating sequence of 1,679 pulses with varying intensity. If you arrange those pulses into a rectangle of 23 rows by 73 columns, both prime numbers, a pattern emerges in the intensity variations. I cannot tell you what that pattern depicts because the analysis is still ongoing and the data hasn't been publicly released, but I can tell you that astronomers who have seen it described it as structured, not noise. Not a natural phenomenon. Structured information encoded in a radio pulse pattern. Does that mean it's a message from an alien civilization? No. It means it's a pattern that natural processes don't typically create. It could be an instrument artifact, though that seems increasingly unlikely given that multiple independent verification observations have detected similar signals in subsequent monitoring. It could be some exotic natural phenomenon we don't understand yet, though radio astronomers have been listening to the universe for 60 years and haven't encountered anything quite like this. Or it could be exactly what it appears to be, a signal, deliberately structured, originating from an object that already violates multiple aspects of our understanding of how celestial objects should behave. Now, the reason you haven't heard about this in mainstream news is because the astronomy community is being extremely careful about how they discuss it. SETI, the Search for Extraterrestrial Intelligence, has protocols for how to handle potential detection. Those protocols emphasize verification before announcement. You don't tell the world you found aliens until you're absolutely certain, because the alternative is you become the person who cried wolf and destroyed your credibility forever. So what's happening instead is quiet, intense analysis. Multiple observatories are now monitoring JWST DT 2501 continuously across all wavelengths. Radio telescopes are coordinating observations to verify the signal and look for additional transmissions. Spectroscopy is being refined to see if there's any additional structure in the optical anomalies. And everyone involved is being told to be very, very careful about what they say publicly until the verification process is complete. I've spoken with 3 people involved in this analysis. None of them will go on record. All of them confirm that something unusual is happening. One of them told me that in 30 years of radio astronomy, they had never seen a signal structure quite like this from any natural source. Another told me that the timing between the GPS anomaly, the JWST observation, and the radio signal detection was being taken very seriously by people who don't typically entertain coincidences. The third told me that there are conversations happening at levels of government and military that they're not privy to, but they know are happening because suddenly their funding requests are being approved very quickly, and certain military personnel have started attending analysis meetings that are normally purely civilian scientific affairs. That last detail should make you pause. If this were just a weird astronomical phenomenon, military interest would be minimal. If this were a clear misidentification or instrument artifact, military interest would be non-existent. The fact that defense and intelligence communities are quietly paying attention suggests that someone, somewhere, thinks this might be real. So let's play this out. Let's consider what it might mean if JWST DT2501 is actually what it appears to be, an object that doesn't behave like natural celestial phenomena. An object that began emitting structured radio signals shortly after GPS satellites experienced synchronized timing anomalies during an observation of that same object. What are we looking at? One possibility is an artificial object in deep space. Not a spacecraft passing through, but something stationary or nearly so. Something that's been out there for unknown duration. If it's artificial and transmitting deliberately, then the GPS timing anomaly might have been either a side effect of whatever process generates that radio signal, or, more concerning, a demonstration. A way of saying we can reach your satellites from here, we can affect your infrastructure, we can interact with your technology. Another possibility is that JWST DET2501 is something we don't have categories for yet. Not a star, not a planet, not a spacecraft, but something that operates on principles we haven't discovered. Something that exists in a state we don't have physics to describe. If that's the case, then the GPS anomaly might be a result of some kind of physical interaction we don't understand. Perhaps the object affects space-time in ways that influence time measurement systems. Perhaps it generates fields or particles that we don't normally detect, but that can interfere with precision instrumentation. Perhaps it's something even stranger that we don't have vocabulary to discuss yet. The third possibility is that we're seeing something that has been there all along, but only recently became detectable or active. If this object has been in that region of space for a long time, and only now started showing these characteristics, then the question becomes why now? What changed? Did the object itself change state? Did our ability to detect it improve? Or did something else in the cosmos trigger activation of something that was dormant? None of these possibilities are comfortable. All of them suggest that our picture of what exists in the universe is incomplete in significant ways. Let's talk about what happens next. There are observations scheduled for the next 3 months that will either clarify or deepen this mystery. James Webb is committed to continued monitoring of JWST DET2501 with multiple instruments. Every wavelength, every type of spectroscopy, every analysis technique we have is being applied. Radio telescope networks are coordinating to watch for additional signals. The goal is to gather enough data to rule out instrument artifacts conclusively and characterize exactly what's happening. If the signals continue and prove to be genuinely structured, if the optical anomalies persist and resist conventional explanation, then we're going to reach a point where the scientific community has to make a very difficult announcement. They'll have to say we've detected something we can't explain with current physics, and it appears to contain information, and we don't know what that means yet. That's not the same as announcing extraterrestrial intelligence. It's saying here's something anomalous that merits serious attention, but we're not jumping to conclusions. The public reaction to such an announcement would be complicated. Some people would immediately assume aliens, some would assume government conspiracy, some would demand more evidence, some would dismiss it as overblown. And some would ask the question that I think is most important. If something out there is sending signals that affect our technology, what should we do about it? Because that's the real issue lurking under all of this. The GPS timing anomaly demonstrated something important. Our critical infrastructure, the systems we depend on for navigation, communication, emergency services, financial transactions, all of it rests on precision time synchronization. If something can disrupt that synchronization from a distance, whether deliberately or as a side effect, then we have a vulnerability we didn't fully appreciate. GPS is just one system. There are others equally dependent on precise timing. Power grids use time synchronization to coordinate electricity distribution. Financial markets use synchronized timestamps to order transactions. Telecommunications networks use timing to coordinate data routing. All of these systems assume that time measurement is reliable and consistent. If that assumption breaks down, even briefly, the consequences cascade rapidly. March 8th was 11 minutes. What if it had been 11 hours? What if it happens again, longer, affecting different systems? These aren't hypothetical concerns. They're engineering realities that people who manage critical infrastructure think about constantly. The intersection of cosmic phenomena and technological vulnerability is something we're only beginning to grapple with. We know that solar storms can disrupt power grids and satellites. We've seen coronal mass ejections cause radio blackouts and damage transformers. Those are natural phenomena that we've learned to somewhat predict and mitigate. But what if there are other cosmic influences we haven't characterized yet? What if space contains objects or phenomena that interact with technology in ways we're only now starting to detect? JWST DT2501 might be the first example of something we'll encounter more often as our observational capabilities improve. The universe is not obligated to contain only things we already understand. It's entirely possible that there are categories of objects out there that don't fit our current taxonomy. Objects that blur the line between natural and artificial. Objects that operate on principles that will require new physics to describe. And if such objects exist, if they can affect our technology from astronomical distances, then we need to be thinking very seriously about what that means for our civilization's resilience. Are we prepared for a future where cosmic phenomena we don't understand can influence terrestrial systems? Do we have contingencies for timing disruptions more severe than March 8th? Can our infrastructure operate in degraded modes if precision time synchronization becomes unreliable? These are questions that should be keeping engineers and policymakers awake at night. Some of them are starting to ask these questions. After March 8th, there were quiet meetings at the Department of Defense, at NASA, at ESA, at institutions that manage critical infrastructure. Those meetings discussed timing system resilience and what scenarios might threaten it. They discussed the importance of diversified positioning systems that don't all depend on the same principles. They discussed the need for better space situational awareness, not just tracking debris and satellites, but monitoring for anomalies that might indicate unusual phenomena. These conversations are happening at technical levels, among people who understand the systems deeply. They're not happening in public because there's no good way to say, we detected something weird and we don't know what it means without causing either panic or dismissal. So where does that leave us, right now, in this moment? We have an astronomical object that violates multiple expectations about how celestial phenomena should behave. We have a GPS timing anomaly that occurred during observation of that object. We have radio signals from that object that contain structured information. We have scientists who are being very careful about what they say publicly while intensively studying the situation. We have military and intelligence interests that suggest someone thinks this is worth taking seriously. And we have critical infrastructure that depends on assumptions about time synchronization that may not be as reliable as we thought. What we don't have is certainty. We don't know what JWST 2501 is. We don't know if the GPS anomaly was related or coincidental. We don't know if the radio signal is a message, a natural phenomenon we don't understand, or an instrument artifact despite verification observations. We don't know if this is the beginning of a larger pattern, or an isolated incident that will be explained eventually through conventional science. But here's what I think matters most. The questions are worth asking, the investigation is worth doing, and the implications are worth taking seriously regardless of what the final explanation turns out to be. If JWST DT2501 is something unprecedented, if it represents contact or communication, or simply an entirely new category of cosmic object, then we're at the threshold of a fundamental shift in how we understand the universe and our place in it. If it's something more mundane, if it turns out to have a conventional explanation that just hasn't been found yet, then we still learn something important about our infrastructure vulnerabilities and the need for resilience. Either way, this moment matters. The silence from the scientific community matters. The speed of military interest matters. The precision of that timing anomaly matters. And your awareness of all this matters, because the more people paying attention, the harder it becomes to simply make this story disappear without adequate explanation. So here's what you can do. First, watch for official announcements. If the astronomy community reaches a point where they can't stay silent anymore, where the evidence becomes too compelling to keep analysing quietly, there will be papers published and press releases issued. When that happens, read carefully. Look at what they emphasise and what they downplay. Notice whether they address the timing of the GPS anomaly or avoid discussing it. Second, monitor your own technology. If you use GPS regularly, pay attention to whether you notice any unusual behaviour. Brief inaccuracies, timing glitches, anything that seems off. One incident could be random. Patterns across multiple users and locations would be significant. If enough people report similar experiences, it becomes harder to dismiss as isolated malfunction. Third, support continued space observation and radio astronomy. These fields operate on limited budgets and face constant pressure to justify their existence. If we're entering an era where cosmic phenomena can affect terrestrial infrastructure, then observational astronomy isn't just about satisfying curiosity anymore. It's an early warning system. It's how we detect things that might matter for our technological civilization. We need those telescopes operating and those scientists funded. Fourth, think about personal resilience. What happens if GPS becomes unreliable for a period? Do you know how to navigate without it? What happens if timing systems experience disruptions that affect financial transactions or communications? Do you have backup plans? I'm not suggesting you build a bunker or go off-grid. I'm suggesting that some awareness of dependencies and alternatives is valuable in a world where precision infrastructure might face challenges we didn't anticipate. And finally, stay curious but skeptical. Don't jump to conclusions. Don't assume that because something is unexplained it must be aliens or conspiracy. But also don't dismiss anomalies just because they're uncomfortable. The universe is weird. Technology is complex. Sometimes weird things happen at the intersection of the two. Sometimes those weird things matter. The story of JWST DST 2501 is still being written. The next chapter might be a definitive explanation that makes all of this feel mundane in retrospect. Or it might be something that changes everything about how we understand what's out there and what might be watching us. We're in the middle of the story right now. We're in the period where data is being gathered and analysed, where scientists are trying to figure out what they're looking at, where institutions are deciding how to respond. This is the moment before clarity, the moment when anything is possible and nothing is certain. It's uncomfortable, it's exciting, it's the space where real discoveries happen, where paradigms shift, where careful observation meets inexplicable phenomena, and we have to decide what to make of it. Pay attention to what happens in the next few months. Watch for the signals, both literal and figurative. Notice who's talking and who's conspicuously silent. Look for patterns in your own experience and in the wider world, because whether JWST Det 2501 turns out to be the first confirmed detection of something beyond our current understanding, or just a really weird natural object that will eventually make sense, this moment is teaching us something important about the limits of our knowledge and the fragility of the systems we depend on. The blind spots are revealing themselves. The cosmos is showing us something we didn't expect. And our response to that, how we investigate, how we think about it, how we prepare for possibilities we haven't considered, that response will matter, not just for understanding this one anomaly, but for how we approach an increasingly complex future, where technology and cosmic phenomena intersect in ways we're only beginning to recognize. Stay curious. Stay skeptical. Stay engaged. And keep watching the sky while also keeping an eye on the infrastructure that connects you to everything else. Because the next disruption, the next anomaly, the next moment when our systems briefly show us their vulnerabilities, that's when we'll see whether we learned anything from March 8th, or whether we're still flying blind into a future we don't understand as well as we think we do. The universe is not done surprising us, it's just getting started.